Hello my dear students, welcome back to chemistry class. Today, let us continue the lesson, Is matter around us pure? Let us revise what we have learned in the previous class. We have learned what are pure substances, what are mixtures. We learned two types of mixtures, homogeneous mixture and heterogeneous mixture. Then we learned what is a solution. Under the term solution, we have learned the terms solute, solvent. Then we learn examples of solution and the properties of a solution. Today we are going to learn what is meant by concentration of a solution and what is a suspension. Let us see what is meant by concentration of a solution. So here you can see three beakers in which equal amount of water is taken and we are adding copper sulfate to this. You know the color of copper sulfate is blue. To the first beaker we have added 1 spatula of copper sulfate. To the second beaker 2 spatula of copper sulfate and the third beaker we have added more copper sulfate. So you can see the color difference here. So here the amount of solute is very less, only 1 spatula. And here little more copper sulfate we have added. And here we have added maximum amount of copper sulfate. So we added more and more copper sulfate. Then the solution will reach such a state that again if you are adding one pinch of copper sulfate also will not get dissolved. So based on this, so here the amount of solute is different in all these three solutions. So based on the amount of solute in the solution, we have dilute solutions, concentrated solutions and saturated solutions. So in a solution, the relative proportion of the solute and the solvent can be varied. Depending upon the amount of solute present in a solution, it can be called a dilute, a concentrated or a saturated solution. So here as the amount of solute is very less, it is a dilute solution. Here little more we added, so it is a concentrated solution. Here we have added maximum amount of copper sulfate such that again we are adding little copper sulfate also, it will not get dissolved in that. Such a solution is called a saturated solution. So let us see the definition of a saturated solution. At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. What does it mean? Maximum amount of solute is dissolved in that solution. Again we are adding the solute, what will happen? It cannot dissolve the solute. So that solution is called a saturated solution. Once again, at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. Otherwise, we can say, in other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. Why we are using the term at any particular temperature here or at a given temperature here? For example, in the previous example, we have seen that we prepared a saturated solution. So, suppose that is at room temperature. Suppose we are increasing the temperature, we are heating the solution. So, suppose we increase the temperature by 10 degrees Celsius. Beginning it was at 27 degrees Celsius. Again we increase by heating the temperature, we increase to 37 degrees Celsius. Suppose the solution at 37 degrees Celsius, if we are adding little more copper sulfate, whether it will get dissolved? Yes, it will get dissolved. So at 37 degrees Celsius, the same solution, we cannot say it is a saturated solution. What is the reason? Again we can add the solute. So at each temperature, the saturation level is different. That's the reason we are using the term at any particular temperature or at a given temperature. For example, room temperature, it was a saturated solution. When we increase the temperature, it is not a saturated solution. Again, we can add the solute and it will get dissolved. Okay, so at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. Now let us see what is meant by solubility. Solubility means how much solute is present in a saturated solution at a particular temperature. So we can define solubility as the amount of the solute present in the saturated solution at a particular temperature is called solubility. Next, let us see what is meant by unsaturated solution. If the amount of solute contained in a solution is less than the saturation level, it is called the unsaturated solution. That means if we can add again the solute, that solution is called a unsaturated solution. So we have learned three terms here: saturated solution, solubility, unsaturated solution. Next, let us see what is meant by concentration of a solution. Concentration of a solution means how much amount of solute is present in a given amount of solution. Given amount of solution means a given mass of solution or a given volume of solution. Otherwise, the amount of solute present in a given mass of solvent or a given volume of solvent. So, how we can define concentration of a solution? The concentration of a solution is the amount of solute present in a given amount. This given amount means it can be given mass or given volume of a solution, or the amount of solute dissolved in a given mass or given volume of the solvent. So here the equation for concentration of a solution. Concentration of a solution is equal to amount of solute divided by amount of solution, or we can say amount of solute divided by amount of solvent. So there are various ways of expressing the concentration of a solution, but here we are learning, in this lesson we are going to learn only two terms, that is two methods, that is one, mass by mass percentage of a solution, other one, mass by volume percentage of a solution. So how to find out mass by mass percentage of a solution? The expression is mass by mass percentage of a solution is equal to mass of solute divided by mass of solution into 100. How to find out mass by volume percentage of a solution? Mass by volume percentage of a solution is equal to mass of solute divided by volume of solution into 100. So we have learned two terms now to find out the concentration of a solution. One, mass by mass percentage of a solution. Other one, mass by volume percentage of a solution. Mass by mass percentage of a solution is equal to mass of solute divided by mass of solution into 100. Mass by volume percentage of a solution is equal to mass of solute divided by volume of solution into 100. Let us see an example how to solve this problem. A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. So, when we are going to solve a problem, what we'll do first? Always we'll write the given data. So, what are the given data here? What is given here? Here, which is a solute and which is a solvent here? Common salt is dissolved in water. So, common salt is the solute and water is the solvent. So, what is given here in this problem? The amount of or mass of solute is given and mass of solvent is given. If mass of solute and mass of solvent is given, we can find out the mass of solution by adding these two. So let us see what is given here. So mass of solute, here the solute means the common salt or simply we can say salt. So mass of solute or salt is equal to, it is given 40 gram of common salt. Mass of solvent, how much it is? Mass of solvent here the water. It is 320 gram. So mass of solute and solvent is given. We can find out the mass of the solution. So mass of solution is equal to mass of solute plus mass of solvent. So 40 plus 320, we are getting 360 gram. Now what is asked to find out here? We have to find out the mass by mass percentage of the solution. How to find out mass by mass percentage? Mass by mass percentage is equal to mass of the solute divided by mass of the solution into 100. So let us write the equation. Mass by mass percentage of a solution is equal to mass of the solute divided by mass of the solution into 100. Then substitute the values. Mass of the solute is 40 gram and mass of the solution is, we have calculated here 360 gram. So 40 divided by 360 into 100. We are getting the answer 11.1 percentage. So we have learned now concentration of a solution. Then what is the definition of concentration of a solution? And what are two expressions we learn? Mass by mass percentage of a solution and mass by volume percentage of a solution. And we have one example sum also we have done. Next topic is suspension. Here we can see one example. Chalk powder or chalk dust is mixed with water. So we are adding chalk dust to water. Thoroughly if you are mixing, we are getting this. And after keeping, if it is undisturbed, if you are leaving the solution undisturbed, this mixture undisturbed, the particle will settle down. So here we can see when this chalk dust is mixed with water, whether it get dissolved in the water? No, it does not get dissolved in the water. Like a solution, so the chalk dust is not dissolving in the water, but we can see throughout the medium, it is suspended here. That is called a suspension. So let us see what is the definition of a suspension. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. So it is a heterogeneous mixture because we can see the particles there. So it is a suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. So let us see a few examples of suspension. So sawdust in water. Sawdust we are mixing in water, it will not get dissolved. We are getting a suspension throughout the medium, throughout the bulk. Bulk means the total, overall medium, it gets suspended. It gets suspended. So wheat flour mixed in water, we are getting a suspension. If chalk dust or chalk powder is mixed in water with water also, we are getting a suspension. So these are the examples of suspension. Sawdust in water, wheat flour in water, chalk dust in water. Now let us see what are the properties of a suspension. So suspension, as we have seen, suspension is a heterogeneous mixture. Next one, the particle of a suspension can be seen by the naked eye, not like a solution. We can see the particle. Another one, the particle of a suspension scatter a beam of light passing through it. So, if you are passing a beam of light through a suspension, we can see the path of the light. You can see the path of light here. What is the reason? This particle of suspension is big enough to scatter the beam of light. As this is scattering the light here, the path of the light is visible. Next, the solute particles settle down when a suspension is left undisturbed. If you are keeping the suspension for a while, we can see all the solute particle gets settled down, not like a solution. Solution, when we are leaving the solution for a long time also, the particles are not settling down. But in suspension, the solute particle gets settled down. So that means a suspension is unstable. We have seen already solution is stable, but here the suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, uh, that means here if you are filtering the suspension through a filter paper, we'll get the residue on the filter paper. What is meant by residue? The particle which is left behind. If you are pouring a solution through a filter paper, we will not get any residue, because solution we cannot filter and we cannot separate the solute particle from a solution. But from a suspension, we can separate the solute particle by filtration. So, when the particles settle down, the suspension breaks and does not scatter light anymore. So, after filtration, what we are getting, the clear solvent we are getting here. So, if you are passing the beam of light through this clear solvent, the particle, we cannot see the path of the light. And here also, after settling down all the particle through this clear solution, if you are passing the beam of light also, we cannot see the path of the light. Here the suspension, this particle before settling down, it is suspended throughout the medium and the size of the particle is big enough to scatter the beam of light. That's the reason we can see the path of the light here. So once again, let us see the properties of a suspension. Suspension is a heterogeneous mixture. The particles of a suspension can be seen by the naked eye. The particles of a suspension scatter a beam of light passing through it and make its path visible. Next one, the solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. So today we have learned the topics concentration of a solution. What is meant by concentration? The amount of the solute present in a given amount, that means a given mass or a given volume of the solution, or the amount of the solute dissolved in a given amount, that means a given mass or given volume of a solvent. This is the definition of a concentration of a solution. Then we learn what is meant by saturated solution, what is unsaturated solution, and what is solubility. We have learned the definitions of all these. Then we learn what are the expressions of concentration of a solution. There are two expressions we learn, mass by mass percentage and mass by volume percentage. Then we learn what is suspension, definition of suspension. Then examples of suspension and the properties of suspension. Hope you understood today's class. Thank you, children.